Hello and welcome to my class. I'm Grolin Annalisi from ThinkMo Education. I'm currently a Cisco Technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is Switch Principle, VLAN and VTP. Let's talk about the technical knowledge of the Exchange network from today. As of last class, we have already finished talking about routing knowledge. Includes static routing, IGRP, and OSPF. Before we formally explain the technology of the Exchange, first of all, we need to develop the entire network. Make a simple understanding. Because when we talk about Exchange today, we must mention a device. Is the switch. So how did the network evolve step by step into what it is now? It is known. Intranet. Switches are very common. Even switching technology for enterprise networks is much more common than routing technology. Then why should there be such a technology? Including how the switch has evolved. I'll draw a picture to explain. Assuming these are the original two PCs. At the beginning, how should the two PCs be connected? It is known. A device wants to transfer data with another device. They are connected by a physical transmission medium. Actually, before the web, all computers are standalone. At that time there was no network cable, no network card, no protocol stack. The overall data transmission is through CD and floppy disk. After a period of time, with the innovation of web records, the network cable appeared. Network cable as physical transmission medium. We can pass data in the middle. Secondly, there must also be a network card on each device. Like switches and routers. The interfaces on them are called network interfaces. The one on the PC is called the network card. Then network cable plus network card. Plus running the same protocol stack on the device. That is what we call the TCP/IP protocol stack. These three constitute an element. We call it the smallest network unit. They can officially start data transmission. I give a simple example. For example, now this cable carries the overall bit stream. That is, electrical signal. Similar to when we call in analog signals carrying voice streams such as. They are responsible for the transmission of signals. Then for the network card. After the network interface receives the incoming bit stream, it converts these bit streams into data. Sent to the protocol stack for processing. Including when it sends data to the outside world. It is also the network card that converts the data into a bit stream. And then sent out. That's like the TCP/IP I just mentioned. I mentioned this when I talked about the reference model before. We are talking about OSI. But actually we are using TCP/IP now. They are equivalent to communication language between multiple devices. That is, in the process of realizing the communication, including analysis of the data, addressing including future addresses. Because the three layers can do addressing, including our control over data traffic. All the same. Here's some of what it does. But with the development of the network, slowly there are problems. Between two PCs. We can't keep them close together forever. Network communication cannot be one computer to one computer. They are very close. Sometimes, we're going to involve some remote data access. Then there will be problems. The transmission medium such as network cable has the upper limit of transmission. The longest effective transmission distance of the network cable is 100 meters. If the two computers are too far apart between the terminals, Once the transmission limit of this network cable is exceeded, then the data starts to be lost. This is what we call lost packets. Your data signal is unstable. Data can be passed, but there will be packet loss. So not now. We will have a way. Add a repeater between these two devices. Just give it a signal amplification in the middle. I draw a device here. This is the repeater. The relay season can complete the amplification of the data signal. Equivalent to. The repeater has received data here. After receiving, it's going to be an integration. Then amplify the signal. Send the signal again. Then it can extend the transmission distance of the network cable. But this device has a problem. That is, it has only two interfaces. It has fewer interfaces. Two interfaces are not enough, because it can only amplify the signal of two devices. Look at me as an example. It has only two interfaces. It won't work if you connect another device here. You can't connect a third device. So there's the next generation of devices. After the repeater is the hub. To us, the two interfaces of the repeater are not enough. Let's change a device now. Called a hub. We still put it between the two devices. Then it is called a multiport repeater. It's no different from a repeater overall. There are more interfaces. So, we put it here now. This is a multiport repeater. A multiport repeater means it can now connect to more devices. Then we can complete the data interaction between multiple devices. Let's briefly talk about how it works. If the hub is now from an interface, received a data, it will directly send a copy from other interfaces. So it's a repeater. That is a working principle of multiport repeater. Well, first thing to know. It is a device working at the physical layer. Actually, it will only perform simple flooding processing on the data. This flooding refers to it received data from an interface. Copy and send a copy of other interfaces. For example, now this PC1 wants to access PC2. Don't want to access PC3. Then this data cannot be forwarded only to PC2. It will definitely send a copy to PC3. Because it handles all data. All other interfaces send a copy. So the hub does not recognize some of the upper layer. IP address or MAC address. So, it has no way to isolate the terminal. Everyone should know this. In fact, this kind of bandwidth utilization is relatively low, because the bandwidth of the link is always occupied. Second, data security cannot be guaranteed. Hub-based networking. Unicast communication is not possible. So that's one of its downsides. We also call this device a hub. Half-duplex device. When you send, others cannot send at the same time. I should have mentioned a concept to you before. Collision domain. The data is within a certain range. If in the process of sending, data collision. This is called a collision domain. Then the half-duplex environment we are talking about is a typical collision domain. Now PC1 sends a data. In the process of sending, this PC3 cannot be sent out. Otherwise it is in a collision domain. The data will be incomplete. The data will be transferred from the original 0101. May be lost in the middle. A few digits are lost or become garbled. It's not complete. So this kind of networking environment is not okay. The transmission utilization rate is relatively low. Of course. We also said before, there is a technology in the conflict domain called CCNA/CD. It can solve problems in conflict domains. But it's too inefficient. So slowly we will find. We want to amplify the signal in the middle. I also want to connect multiple terminals in the middle. Also hope the collision domain isn't that big. Now there is no way to solve this problem. So how to solve it? We came out with a new device.